Well, good evening. Welcome to Space Oddities. Thank you for joining us on this Tuesday evening. Joined this evening by, the usual suspects. Dave, Roger, Daz and Michael. Lou can't be here tonight because he's at a NASA seminar thingy. So anyway, tonight on Space Oddities, as you may have seen in the news, in a move that has horrified the British astronomy and physics community, the government has announced that they are stopping funding for the legendary and vitally important Jodrell Bank Radio Observatory, which has been a mainstay and focus for radio astronomy since it was constructed in 1945. So tonight we're going to give you the full rundown on exactly what's happening and why. And there you are. So just before we do that, let's have a quick look in the chat. Hi everybody. See, we got some usual people there. Welcome back, Deep Burrito. Don't worry, Daz has been thoroughly flagellated from the chat last week, so we're really, really sorry about that.
Flatulated. I thought you said flatulence. Sorry.
No. So don't worry, we won't happen again. Okay, let's move on and get on with this.
You've just ruined my image, Andy, because I'm sat here with my stern look on, and you made me smile. Ruin the effect.
Anyway, we're going to start with you, Daz. So would you like to give us some information, please, about exactly what's going on with Jodrell Bank?
Okay, then, please. Well, this is more a rundown of basically the history of the budget of the UK space industry. And as you can see, the first slide is Rest in Peace, UK Space Agency, 2010 to 2024. As we know, back in 2024, the UK, in their infinite wisdom, decided to scrap the UK space industry. And basically, they put them into another department, which was space, which was science and technology. And as soon as we saw that, we all said at the same time that this is the end of the UK space industry, because all the cuts will be in physics, astronomy, and space, anything to do with space and things like that. So please, I'm going to sort of like waffle through these, unfortunately. The reason being is that in a bit of confusion, we thought we were doubling up on our things. What's going on here? All right, let me just do this. I do apologize. It's a bit of a fluster because I was actually doing this about 5 minutes ago, trying to get this all up together. So I need presenter view. There we go. So you can still see everything. Yeah. Okay, peoples. So this is basically a history of the UK government spending on the UK space program, 2013 to 2026. And basically it says the trajectory of the UK's government investment in its space program has been considerable, has seen a considerable evolution over the past decade, shaped by a complex interplay of ambition, economic challenges, geopolitical shifts, and changing public priorities. From 2013 to 2026, the landscape of UK space spending has marked by ambitious initiatives, sufficient funding cuts, and a reorganisation that culminated in the demise of the UK Space Agency, as I said. This overview explores the tumultuous period, highlighting key events, funding levels, and their implications for the future of UK space endeavour. 2013 to 2016 was sort of like a bit like the real start of when money started to be ploughed into the space, the UK space agencies. So the early investment is 2013, citing a desire to capture a significant share of an estimated global market worth 400 billion by 2030. The government committed substantial funding to the UK Space Agency, which had been established in 2010. The UK...
sorry, can I interrupt 1 second? Can you
get rid of the cursor?
Get rid of your mouse pointer. Thank you.
We were there. The UK Space Agency became a key entity benefiting from the increased budget to support various initiatives, included satellite technology, Earth observation, and space science missions. By 2014, the sector was valued at 11.8 billion, and that's what it was paying into the UK economy. And the government committed approximately 310 million annually to space activities under the UK's national space policy. And so basically, for 310 million, they were getting 11.8 billion back. This period saw the establishment of critical programs aimed at advancing satellite technology, Earth observation, launch capabilities. Notable initiatives included the UK's participation in the European Space Agency (ESA) programs, focusing on collaborative projects and contributed to shared scientific endeavours. Well, that didn't last a bit. The UK Space Agency also invested in developing UK spaceports in Scotland and Cornwall, positioning the country as a potential launch hub for small satellites and fostering a burgeoning domestic industry. And if you look at the slide we're at on there, in the bottom right hand corner, you can see where they were planning to. They gave licenses for people to build launch facilities. And also, you'll also see they're what they call the space activity centers, which is where basically anything to do with space or any company with space could actually come in, and they would actually be sort of like hubs of space activity, so that people can all already work together. Um, so so that's what they promised us. And as I said, we had policies, we had strategies, we had all these papers come out. And basically, it's all come to naught, unfortunately, at the moment. It says the government initiated the UK space strategy in 2015, which set clear objectives to expand the UK's workforce, enhance international collaboration, um, and develop a national satellite navigation system in response to potential post-Brexit discrepancies. Sorry, my glasses fell off. Funding from the UK Space Agency supported diverse projects from academic research to commercial ventures, leading to a flourishing of small satellite launches and the development of new technologies overall. The early years of this decade reflected a significant governmental ambition to position the UK as a leader in space, with an eye toward economic growth and technological leadership. Though ambitious, this period also faced challenges concerns regarding the long-term sustainability of funding began to surface, particularly with the backdrop of the UK's growing political focus on austerity and domestic issues. The gradual shift and Brexit complications. The 2016 referendum on Brexit introduced a wave of uncertainty, significantly impacting policy decisions and government spending priorities. While initial post-Brexit commitments remained steady, the implications of leaving the EU or on collaborative projects, funding, and regulatory frameworks became increasingly apparent. Despite pledges to maintain investment in space and economical climate shifts, the overall priorities began to evolve. By 2018, the UK Space Agency's budget remained at about 4.6 million, but came under increasing scrutiny as public spending tightened due to austerity measures. Government funding for space exploration directly competed with demands in healthcare, education, and infrastructure, leading to a reallocation of financial resources. Unfortunately, this meant that scientific disciplines, particularly astronomy and physics, saw a reduction in investment, critical areas that had historically benefited from sustained UK government support. Notable cuts began to surface in funding dedicated um, to astronomy, physics, and astronomy and physics, particularly in university programs, redirecting emphasis on short-term technological gains. This gradually eroded support for research programs reliant on stable funding, causing alarm among scientific communities concerned about the long-term impact on the UK's scientific prestige. Despite, excuse me, prestige. A significant example of this shift was the diminishing funds for pivotal national radio astronomy projects like the Merlin programme. While the UK had historically contributed to pioneering efforts such as the International Square Kilometre Array project, funding was increasingly diverted to pressing domestic priorities. This slide here is basically just showing you what another initiative that was set up by the government called Catapult. And what this was to do was to, again, as you can read there, it said Catapult helps organizations make use and benefit from satellite technologies and bring together multidisciplinary teams to generate ideas and solutions in an open innovation environment. So basically, this was set up to actually try and get people, and this was going to be part of the Space Activity Agency centers, was where this was all going to be pulled together, and people who were working in different areas of the Space Agency in the UK could be pulled together to resolve problems and also to advance the UK space industry. So this was called Catapult. But there was also another blip on the horizon that was looking for us. So COVID. So the decline and commitment of program goes. As the decade progressed, particularly in 2020, the impact of a COVID-19 pandemic further strained government resources and prompted drastic changes in budget allocation. The UK Space Agency budget immediately decreased from around 250 million by 2021. Cuts began to affect programs essential to the broader research framework, particularly initiatives tied to radio astronomy and space science. The removal of funds for specific radio telescopes in the UK, including the Max Planck Institute of Radio Astronomy collaborative work, highlighted a disinterest in maintaining some legacy areas of scientific inquiry. Similar cuts were observed in international projects, including the famous Square Kilometre Array project in Australia and South Africa, where the UK's contributions were diminished as funding strategies realigned. Well, of course, I mean, as we will hear a little bit later on, Jodrell Bank was supposed to be the home of the actual management system. They were going to actually run the whole system from Jodrell Bank in the UK. In 2022, the combination of Brexit budget tightening and an increasingly fragmented space strategy led to further cuts across various disciplines. The UK government announced drastic reductions in astronomy funding at home, impacting both emergency research projects and institutions. Consequently, the viability of domestic observatories such as Jodrell Bank faced existential threats as they scrambled to sustain operations on curtailed budgets and staff cuts. During COVID, the staff at Jodrell Bank was drastically reduced. The demise of a space agency and final cuts. As the UK government commitment to space dwindled, the culmination of these budget constraints and policy shifts ultimately led to the disbandment of the UK Space Agency. The agency, once a leader in promoting the UK's interest in space, was restructured in 2024 and absorbed into the Science and Technology Facilities Council. Let's all hear a boo. Boo! A larger governmental research framework was prioritised more immediately on societal challenges over long-term scientific objectives. This deeply troubling development is one of several heavy blows to UK astronomy brought about by widespread funding cuts by the Science and Technology Facilities Council. Another boo. Boo! It follows the news that the STFC is withdrawing all funding from E-Merlin, which is the Enhanced Multi-Element Radio Link Transformer, a radio-linked interferometer network. Sorry. So this is the E-Merlin. Well, let me just go back because I've lost my notes there. Facility. E-Merlin, Enhanced Multiple Interferometer Network, a group of 7 UK radio telescopes, including the iconic Lovell telescope at Jodrell Bank, that make up the world's most powerful stargazing systems, one of the most powerful systems. Other casualties, so all of these, there's 7. I'll flick through the slides. As I said, this was a bit of a rush job. All of these 7 observatories now all face closure, and that includes Knockin, which is about 5 miles away from me, which is very, very, very sad state of affairs. Other casualties in the long list funding include UK withdrawal from the James Clerk Maxwell telescope in Hawaii, and our collaboration there. 20% cuts for the UK Square Kilometre, I'll get it right, Kilometre Array Regional Centre. As I said, that was going to be at Jodrell Bank. And activities at the Vera Rubin telescope in Chile, which we know has just come online. While the Bison Solar Observing Network will suffer cuts of 40%. So that is basically the UK's solar observing network basically gone. This reorganization sparked widespread criticism from the scientific community, who warned that the UK was at risk of losing its leading role in the international space sector. The focus shifted away from strategic planning and exploration, leading to a fragmented approach to space initiatives. The absence of dedicated administrative body made it increasingly difficult for the UK to navigate the complexities of international partnerships and funding opportunities. I'll just flick through these slides. So as I said, you've got the E-Merlin. All of these radio telescopes now face closure and mothballing. The James Clerk Maxwell telescope in Hawaii, our collaboration with that is now disappearing. Our major involvement in the SKA, as I said, we were going to be the management center, is all going to be run from here, is now in jeopardy, if not, it's gone completely.
Can I interrupt on that, Daz?
Yes, certainly.
I've just found a quote from Tim Rocker MP, who's the Member of Parliament for Macclesfield, the constituency that Jodrell Bank is in.
Yeah.
And he said the STFC has also confirmed that its investment in the SKA at Jodrell Bank remains one of its highest priorities and will continue. So it looks like the Jodrell Bank being at the centre of the SKA will continue. However, that's what he says. So I
was just wondering, but without a budget, will they be able to fulfil that role?
Yeah.
Because all the money is being basically pulled. Well, most of it anyway.
Yeah.
One of the other casualties is Bison, which is a Birmingham University collaboration. And as you can see, this is again another interferometer of several telescopes. And of course, we have the Lovell telescope, which the headlines for today were Jodrell Bank Observatory is facing closure amid reported 2.8 funding cut. Observations will end in April 2028 unless new funding can be found. And that's what all of our headlines have been over the last week or two. So if I can just get rid of this for you. There is one more thing I would like to just wait. I'm back in the studio. I just want to get rid of this. And what I would like to also talk about, we've lost Michael.
Michael sent a message saying he's had a power cut.
Oh, okay then.
He's just getting everything back online, so hopefully he'll be able to join shortly.
The other thing I would just like to talk about, and I will have to do this blind sort of thing, is that the UK space industry has made significant contributions to the UK economy over the years. Basically, I've got a list here of what the actual how much money the actual our space industry brought into the UK itself. So in 2013, it was 11.3 billion. 2014, 11.8 billion, as we said earlier. That's that. And then it's 12.5 billion in 2015, 14.8 billion 2016 and onwards, and it peaked at 16.5 billion for the years 2018, 19, and 20. And then it was it peaked at in 2021 it was 17.5, and then in 2022 it was 18.8 billion. So this is money for the small amount that we are actually putting into this. We were getting a huge I know it's not on NASA scale events, but then of course with the demise of the space agency, we stopped getting any information through. So 2023, the projection was it was going to be 19 million. 2024, 20 billion, and then 2025, 21 billion to 22 billion. And I did read somewhere that by 2030 they thought it was going to be probably as high as 40 billion, if I remember right.
I mean, that's a huge sum of money.
Of course, it's money down the drain. They're not going to get that now.
Yeah.
And we were talking earlier, and we were basically saying that with the lack of foresight on making these such drastic cuts, other than taking us back to the dark ages, it's going to the knock-on effects. There's going to be, I mean, who's going to bother coming to the UK to develop space technologies if there's no interest in the UK? Who's going to come and?
Yeah, I was going to say, Dave, what do you think about all this as an American?
I mean, it's a shame, and we were seeing the same thing happen in NASA, and they seem to be these draconic cuts they keep talking about, and then they kind of come up and kind of save it, but it's damaging. It's damaging nonetheless. But I mean, to see this happening in with everything in Great Britain and in ESA, I guess. I mean, some countries seem to be holding firm with their space programs. No, it's a shame, because I've always thought the more the merrier. I mean, get more and more people involved in the space program. We will get more and more information, and more missions, and especially the collaborations are really valuable. And I assume you'll be. I don't know. You'll be losing a lot of that as well.
Well, yeah.
I think the fact that Britain's involvement in Vera Rubin looks like being curtailed, and all these other big projects as well. The James Clerk Maxwell telescope, which was built by the UK, and has been an amazing infrared instrument for decades now. Sort of unthinkable that could close as well. It's just, Deep Burrito says quite rightly. Let me put this up on the screen. Space is being moved into the private sector. In fact, it's not just space, is it? It's science in general. That if it doesn't either make a buck or align with government's political objectives, then it gets cut. And we are seeing this in the US with
Yes.
Trump's defunding of NOAA, for example, and anything that is remotely perceived as politically incorrect.
Well, and right. I mean, climate change research, at NASA has been under fire for a decade, really. I mean, it's not just but the other real drawback for us, for America, for NASA is it's a big selling point if we can propose things that involve international collaboration. Congress likes seeing that. That's something. Oh, we're going to collaborate with ESA. We're going to collaborate with Japan, or whoever on these big projects. And if that starts dropping out, it's likely that they'll just say, well, we're not going to pay for this all by ourselves, so we're not. We're just not going to fund this, and that's another worry. Yeah. So
I mean, one of the worries with your budget restraints was the brain drain. Well, of course, it's the same here now. I mean, the universities are going to suffer massively through this because the research that was done, a lot of it's at the universities, is being curtailed. And who wants to come to the UK to study at a university in a country that doesn't support the space industry and is almost backward looking? And it's just a massive mistake. But it's just very, very sad. The whole thing's very sad. I mean, for the sake of a few $100 million, they were getting billions back. And now it's going to cost them even more because these companies are going to say, well, we're going to go somewhere where they're interested in what we're doing. So the employment rate's going to go up. All these people are going to become unemployed. So now it's another burden, a further burden on the taxpayer. It's mad. I don't get it. There you go.
Can I just, Michael's managed to get back. There he is. Oh, or not. There he is. Hi, Michael. Can you hear us? Obviously not.
Hello, Michael.
It's statewide power costs. Some house alarms still going off.
See, it's more cuts from the government, Michael. See, you've been cut off.
Yeah.
I was going to say, viewers. I mean, I'm sure none of you watching today would support in any way these cuts. So, what are your views? What do you think? What do you think Britain should be doing about long-term science funding? Because, in any economic climate, especially one where Britain is trying to up its defence spending, it's always science that gets cut. And, all of this spending ought to be ring-fenced in some way. And so if you have any views, yes. So I'm really saddened by the prospect of Jodrell Bank telescope losing its funding, having visited the telescope only last month. Yeah, absolutely. Yeah, it's just, thank you for that. It's just unthinkable. And Deep Burrito says orbital telescopes and full spectrum telescopes will be the norm with laser downlinks 24/7. Yeah, that may well come. But at the end of the day, the pot of money for science is just shrinking and shrinking. And, under the Conservatives, they did a lot of good things for space, setting up the space agency and whatever, but then it was cut again. So, we need long-term investment. I mean, any youngsters thinking of going into science as a career these days, how can they possibly make any plans for their future, knowing that at any moment their funding could be cut and they'll be out of a job? So it's not a good time. Sandra says she's going to Jodrell Bank again this November. Deep Burrito says Starship is projected to bring cost of launch down by 100 times. Yeah, that's right. I mean, SpaceX are saying that. I mean, we could be talking Elon money again, but basically, eventually Elon said that a Starship launch will cost about $2 million. as against 4 billion for the SLS. So this will happen. It's inevitable. It's inevitable because SpaceX started a ball rolling that people are now trying to catch up with. So could these telescopes be bought up by private interest? Well, if there's a buck in it for them, I'm sure. But if it doesn't make any money for them, I don't see any private companies investing unless it's going to make some money. We don't want science to make money. We want science to be a profit-free discipline. That's what science is. It's not there to make money.
But then, ironically, it does.
Ironically, it does.
That's the point that goes over everyone's head. I think is it makes a ton of money. Even the basic research ends up, paying for itself many times over.
Yeah,
it's just too bad.
It is. And Ian says we really need to ring-fed science funding. It's far more important than people realise. So many discoveries and innovations that have changed the world. Absolutely, totally agree. And so Derek says.
Sorry.
Derek says that he says I heard that Jodrell monitored Russian satellites, among other things. So maybe all this in the news is scaremongering.
Yeah.
And also remember they nicked the first image from the moon.
From the moon, that's right.
Right.
Yeah, but from the far side of the moon.
Yeah, in the Daily Express. It was Daily Express.
In the UK papers before the Russians did.
Yeah.
Yes, and our first, all our first indications of Russian missions, like Luna 2, I guess when it impacted the moon, that came from Jodrell Bank was monitoring the radio signals, and when they stopped, they knew exactly when it had impacted the moon, and reported that, which was something, of course, the Soviet Union wasn't reporting, at least not in real time. But they did a lot of that. Actually, Jodrell Bank was spying on the U.S. as well.
They were spying on each other. Everybody knows that.
Yeah. Don't say you weren't looking at us.
Yeah, exactly.
On that note.
Yeah. Deep Burrito says the only UK company I know is Philronic. They now supply the transmitters for Starlink. They grew 350% this year. So yes, I mean for sort of niche applications like that have the potential for making money, sure, private companies will invest, but things like astronomy, don't really make money. It's just research, basically. So there we are. All right, well, let's go over to Michael and hope his power stays on.
Yes.
Michael is going to tell us a little more about what's been going on with Jodrell Bank.
I am. Just bear with me a second. Oh, sorry. I've got to start again, of course. So.
Yeah. On a lighter note, if the aliens want to say hello, we won't hear them in the UK.
Yeah.
Very true. Very true. Thank you for that.
Yeah. Okay. That's the one I want to share. Oops. Yes. Okay.
Great.
All right. So this is called Cutting the Cosmos, UK government budget cuts to a science in astronomy from 2015 to 2026. A decade of underfunding and what it means for Britain's space place among the stars. Britain's proud astronomy legacy now under threat. Foundations of modern science. Just hold on a minute. Right. Yeah, UK scientists discovered the electron, decoded DNA, built the first computer. All blue sky research with no immediate commercial application. Nobel Prize-winning nation. Peter Higgs, the British theorist, won the 2013 Nobel Prize in Physics for predicting the Higgs boson, a particle believed to be that hold the cosmos together, confirmed at CERN nearly half a century after his prediction. A reputation now at risk, the UK astronomy and physics community remains internationally recognised, but decades of investment are now being unwound, threatening that hard-won standing. So from 2010, the science Technology Facilities Council, that you've heard that in Daz's talk, the STFC, received flat cash settlements, meaning its normal budget barely moved for years. But in the real world, costs kept rising. By 2014-15, 4 years of flat cash had delivered a 10% real terms cut, driven by inflation, soaring energy costs, and expensive scientific equipment. STFC issued a stark warning to the government. A further 5 years of flat cash will lead to accelerating declining programs towards the closure of major facilities, loss of skilled people, and economic impact and international competitiveness. Those warnings went largely unheeded, and the trajectory continued, and now we know what's happened. So who controls the money? The UKRI, or the UK Research and Innovation, allocates the funds across the councils, including the STFC, the Science and Technology Facilities Council, distributes to facilities, subscriptions, and grants. HM Treasury provides overall government's research funding, and the STFC sits within the UKRI, the umbrella body for all UK research funding, and receives roughly 800 to 900 million pounds a year. 2025 to 26, the crisis breaks. We had 162 million pounds in cuts, roughly 20% of its entire budget. Particle physics, astronomy, and nuclear physics funding projected to fall to just 70% of 23 to 24 levels in 6 years. Project leaders across the country were asked to model what 20% and 40% and even 60% of funding cuts would mean for their work, and to identify the funding points at which the project becomes non-viable. This came after a 15% cut to support particle physics, astronomy, and nuclear physics research. The previous year had already destabilized careers and programs. Okay, this is a slide showing where the UK lies in the amount of spending for science and technology and space and civil space and research and development spending in comparing with the rest of Europe. As you can see, the UK is fifth in the program, with France first, Germany second, Italy third, and Spain fourth.
Yo.
Yeah. Okay. All right. Jodrell Bank and ICANN goes dark. Zero funding confirmed. On 27th of July 2026, UKRI confirmed zero funding for emailing the network of 7 radio telescopes anchored by the iconic Lovell telescope at Jodrell Bank. The entire Jodrell Bank observatory faces closure unless alternative funding is found by 2028, potentially impacting the work of nearly 3,000 scientists who rely on its facilities. Oops. Oh, you are done. Okay. Okay. Other UK projects losing funding in 2026. At CERN, the Large Hadron Collider, the UK is cancelling its contribution to a key LHC upgrade, while Atlas CMS, or Compact Muon Solenoid and Massive Particle Detector at CERN, and LHB-CB, the Large Hadron Collider Beauty experiments, specializing in investigating the slight differences between matter and antimatter. UK participation in the deep underground neutrino experiment involving 13 universities and two national labs has been reduced, weakening British involvement in one of the particle physics most ambitious international collaborations. Hypercam and Ultracam, two world-leading high-speed optical cameras designed to study the universe at extraordinary precision, have been entirely defunded. Both provided crucial data for the Vera Rubin Observatory in Chile, an international facility now losing its UK partnership, unfortunately. Okay, the brain drain, as is just a note of what a scientist has said. You're killing the tree by removing the roots, said Dr. Simon Williams of Durham University. Addressing MPs, Dr. Williams is among 30 young physicists who were unable to secure grants in 2026 after STFC delayed funding decisions while planning its cuts. Many of those affected are described as the brightest scientists in their field, now forced to seek research positions overseas or leave academia entirely. Hundreds of early career researchers signed an open letter warning that the UK will lose a generation of scientists, people who have spent years in training only to find the door closed at the moment that they were ready to contribute. Which is right. Okay, so this blue sky versus applied is about a new funding model spread over 3 buckets, as they call them. Bucket 1 is blue sky research. Only 8.8% of UKRI funding goes to what most would consider curiosity-driven research. Yet this research historically is the foundation of all future applied breakthroughs. Bucket 2 is government priorities, which are artificial intelligence, which raised at £1.6 billion, quantum physics received £1 billion, and the national supercomputer is £750 million. And bucket 3 is business commercialization, helping companies develop new products. What needs to change? You cannot talk about science superpower while trying to ramp up defense spending and pretending the overall budget does not bite, says Andre Guilhem, Nobel Prize winning physicist. So what needs to change? We need to ring-fence discovery science. The Royal Astronomical Society calls for protected long-term funding for curiosity-driven research. Transparency in cuts, decisions about which projects survive should be made openly with proper consultation. Invest in early careers. The pipeline of future scientists must be protected, delaying grants and removing fellowships. Delaying grants and removing fellowships does not save money in the long run. And that's it. And I've just put
okay. Thank you very much, Michael.
There for you.
Thank you very much. So the question is really, what can we as individuals do? Well, there is a petition circulating online against Jodrell Bank being cut. I'm sure you could Google that by just searching Jodrell Bank petition, I would imagine. And apart from that, you can of course write to your MP expressing your concern about these cuts. It may not achieve anything, but we have to do something to stop these awful cuts going ahead, or at least find alternative sources of funding. But as we said, where that would come from, we don't know. So yeah, Mike Beer says so many discoveries come about purely by chance. This is so short-sighted.
Definitely.
Definitely, Mike.
Well, I mean, Michael talked about Nobel Prize winners, where you look at Jocelyn Bell Burnell when Ryle and what was his name? They got the Nobel Prize for finding and discovering pulsars.
Yeah, absolutely.
So, and that was serendipitous. You know, they built the radio telescope in a field,
Yeah.
And luckily, just
Anthony Hewish.
Anthony Hewish. That's right. Yeah. That's it. He was her supervisor. That's right.
Yeah.
And Royal was the main chap at the top. But that was basically just due to somebody looking at miles of scribble lines, and she noticed a bit of scruff, as she called it, and then she noticed it repeated. So that's how things work. I mean,
well done.
Thank you, Sandra.
Yeah. Yeah, I think we've all signed it here, I think.
Yeah. I mean, apart from writing to your MP, I don't think at the moment there's a lot we can do until there's some definitive news about exactly what's going to happen. Michelle Doherty, the Astronomer Royal, seems resigned to these cuts actually happening, from what she's said. And let me just read you a couple of quotes here. So Professor Simon Garrington of Jodrell Bank told the BBC that, as Daz said, Michael said, unless alternative funding can be found by April 2028, that's it. There are 28 jobs at Jodrell Bank itself at risk, but the closure could affect the work of more than 3,000 scientists. And he says Jodrell Bank and its telescope network have been a beacon for science in the Northwest, attracting young people into science and engineering careers. Michelle Doherty, who, as well as being the Astronomer Royal, is executive chair at the UKRI, said, after listening to our community, we protected core discovery research. However, the situation does require some tough but necessary decisions. And they do plan to challenge the decision while trying to find alternative funding. So there we are, and that's the situation at the moment. Of course, we will keep you posted of any developments with that, and if there's any other way that we can, as concerned astronomers.
I think you've only got to look at the amount of visitors, public visitors that Jodrell Bank get each year.
Yeah.
Especially after this new visitor centre that was opened 4 years ago, which is absolutely amazing. And all the interest it creates as well.
Yeah. And Anne says terrible decision. The space industry brings lots of jobs result. Absolutely, Anne. It's so short-sighted. And the question is, does Britain want to be a leader in science or not? And the government always claim that it does, but as always, the funding is an issue. So there we are. Okay, well, we'll leave Jodrell Bank for now. Thank you so much for your comments, and we will we'll move on. I want to thank those of you who joined us last Friday for the Starship Flight 13 flight, which if you joined us on Friday, it was a really, really exciting time. Just want to do a quick recap of that for those of you that may have missed Flight 13. It went nearly flawlessly, apart from the fact that the Super Heavy booster didn't or couldn't fire enough engines for its landing burn and hit the Gulf of Mexico rather harder than was intended and was lost. But apart from that, the Starship itself performed absolutely flawlessly, including all of the experiments that were done. The first one was to basically accelerate it faster after launch so that they could test how the heat shield ties performed under increased stress and pressure. The Starship deployed 20 actual Starlink satellites, the newest version 3 Starlinks. And the test was to see if they could communicate A, with the Starship, and B, with each other using lasers. So that was a really good experiment. They all did. All 20 of them performed flawlessly. And because they were only up there for an experiment, they descended into the atmosphere and burned up after 20 minutes, which was the intention. Starship managed to relight one of its Raptors, which would be crucial for in-orbit flight. And the great thing was that the heat shield, which SpaceX had been working on so hard to get right, seems to have gone largely unscathed. So let's just do a quick recap of the mission itself, starting with the launch.
-9, 8, 7, 6, 5, 4, 3, 2, 1.
A fantastic launch. Flawless, at last. And then the moment came for the separation of the booster and the Starship, which, as you may remember, had been quite well. And we had this lovely video of the vehicle separating. Look at that. That's absolutely amazing stuff. And this, let's just look at a still from this. This is absolutely beautiful. Let's zoom in a bit on the Starship. And, you know, for those of us that grew up with books and magazines from the 50s and 60s, this was pure 50s and 60s sci-fi, a sci-fi rocket ship at last.
Yeah.
Dan Dare and Flash Gordon come to mind.
Yeah, absolutely. This must be the image of the month, at least, if not the year so far. I think that's absolutely incredible. So then came time for the Super Heavy to descend, and as I said, it tried to light, I think, 18 of its engines for the landing burn, but only 6 of them lit, and 3 of the ones that lit stopped lighting a few seconds later. So this was video from the Super Heavy booster descending towards...
Awesome shot. You can see it there. So right now the booster is using their 3 hypersonic grid fins to guide itself through the atmosphere toward its landing site. You can see we're only 5 kilometers above the sea right here.
Startup.
Just heard the call out for landing burn startup for the booster. I have a feeling the crowd's about to go wild here.
So that was that. But the amazing moment, as you probably know, on every single flight that the Starship has splashed down in the Indian Ocean, it's fallen over, seawater has got into the rocket, and cold seawater meeting extremely hot metal has ruptured the fuel tanks, and the whole thing has exploded. Not this time, as you will see.
As we get it.
And here's the Starship
we didn't
descending.
do any real stress tests or anything on this flight. We did do, you heard our landing large flight controller call out. We were doing the swoosh maneuver. This is kind of the final maneuver that we plan to have starships returning to Starbase do, that will essentially hook them out over the Gulf before coming in and over Tower 2. But about 10 seconds away, look for 3 Raptors, the 3 in the middle, to light up, do a flip. Let's see if we can get this thing in the water.
Wait for the belly flop maneuver where the rocket goes vertical.
3 sea levels lit. Seeing healthy chamber pressures on. Did our flip down to 2. Starship descending into the Indian Ocean, down to 1. And we're in the water. And it's a soft splashdown in the water. That is a first. That is the softest splashdown we have ever had with the Starship.
Well, there you are. So that was the Starship mission. And in fact, the Starship continues to fly. There was a bit of fuel, but a bit of methane burning off there, which are the flames you saw. But the Starship remained intact, which was the first time that's ever happened. We believe the latest plan is to tow it probably to Australia. They're not going to tow it all the way back to Texas, but they're going to apparently try and get a boat out there to tow it back to Australia. And then move it back to Texas, but we've yet to confirm that. If they could, that'd be great, because it definitely should go in a museum.
Exactly. I mean, the delay has been the fact that they're, as we saw, obviously there was some split in the fuel tanks because we had the small fires, But they think that possibly some of the tanks could be still pressurized. And that's why, and also they're concerned about the self-destruct explosives on board. If they've been compromised by the seawater and become unstable. And of course they wanted to vent them, but unfortunately the way it landed, the vents are actually under the water.
Underwater, yeah.
Yeah, and they were worried that as they vent, water will seep in and it'll sink. So it's taken them a few days to decide what they're actually going to do.
And
but I did see. Sorry.
No, I was going to say that they moved very quickly. They had a drone out there very quickly flying over the starship, examining those heat tiles. So that's a lot of data they've got back. If they do manage to actually get the starship itself all the way back to Texas, they'll have an absolute goldmine of data.
Yeah.
So
I mean, the tiles looked wonderful. There was some ablation. There was some with pits in. But what amazed me was the beautiful patterns that were left on the actual surface and all that. And if you notice, if you go back and look at it, when it was on its back and it was dipping up and down, that was some sort of a soft ablation, because on the actual wings, the flaps, it actually washed off in the seawater, so it wasn't anything
no, it wasn't anything
drastic.
structural. No,
and it was but you could see some of they had suffered, but they've been designed, and the reason that the actual design is that they can be taken off and replaced individually. Whereas when you had the shuttle, each piece was made, it was numbered, and it was actually designed for where it was going to go. So you couldn't just take another one, slap it back on. You had to go into the library, find which one you wanted, and put that in, because that was specifically made for that part of the shuttle. So
And Bob asks if the starship was designed to float. No, it wasn't designed to float. It was just a stroke of luck that it did more than anything, I think.
I must admit, I did wonder whether or not they'll get a jet fighter come along and blow it out of the water like they did. Can you remember the booster that was floating in the Gulf?
Oh God, yeah. They had
to get the Air Force. It gave them a bit of target practice, and they had to shoot it up so it would sink.
Okay, so
there was a hazard to shipping.
Flight 14. The next flight is next month. They are moving now to a launch cadence of once a month, and Elon Musk has said, as long as the data that they've got back from Flight 13 doesn't show anything particularly anomalous, on Flight 14 in August they are going to catch the Starship with the chopsticks. So in other words, Starship will go orbital for the first time. It will do one orbit around the Earth, fly back to Boca Chica, and be caught by the launch tower. They're not going to try both of them. They're still going to dump the booster in the Gulf of Mexico, because they don't want to risk losing the tower before they've had a chance to catch the Starship. So the booster will splash down in the Gulf of Mexico, hopefully somewhat softer this time, and the Starship will be caught. So join us for Flight 14 next month. We will be covering it. We haven't got a date for it yet. We will let you know as soon as we have. Okay, let's move on. So what we're going to do now is to go over to Uncle Dave, and Dave with his wonderful look back in history for this week. So what have you got for us, Dave?
Okay. Yes, I got 2 weeks worth now, since I wasn't there last week. So there we go. Okay. All right. So yeah, all right, let me get started. I have a lot, so I'm going to run through some of these pretty fast. But let's start out July 19th. So Imp 8, which is, this was Imp E, which was Explorer 35. It's the only actual sort of dedicated moon orbiting space physics mission in the early years anyway. But these interplanetary monitoring platform explorers went to space, just in general, they would go out in space. They go in heliocentric orbits. They go in large Earth orbits, that sort of thing. And they were just monitoring space, not any particular planet, just what was happening with the sun, the magnetic field, things like that. And so this was the one that went to the moon, was launched in 1967, and returned quite a bit of useful data. Sort of discovered the fact that the moon had no magnetic field, but still act as this blockade to the solar wind and the solar wind magnetic field, so that there was this sort of dead area behind the moon, which they had, not known, had been theorized but not known, and it was quite a successful mission. 6 years of orbiting the moon and returning data, and they finally let it impact the moon, which is what happens to anything that's orbiting the moon, because the moon's gravity field is very rough, and just nothing lasts very long usually. Once it runs out of fuel to keep it in orbit, it usually, because of the mass concentrations on the surface of the moon, the orbits don't last very long, and they usually decay pretty quickly. And this thing crashed, and no one knows exactly where it crashed. They don't know exactly when or where it ended up coming down.
Oh, shame.
Yeah. We could look for the the impact site, but it hasn't been found. But it's hard to find when you have no real information about it. Yeah. So, okay. So, whoops, I'm losing it. Okay, here we go. Yeah, this is kind of cool. This seems a little bit ahead of its time. This CERT mission, the Space Electric Rocket Test, is the first ion thruster ever operated in space, and that was in '64.
That's amazing, because you normally think of ion thrusters as being something quite modern.
That's right. It really it's it actually surprised me when I very first saw this, that that it was so early on. In fact, there's even there's a quote in Star Trek from the episode Spock's Brain, where Scotty is talking about, he says, I've never seen like it. They saw a ship. They see the ship in space, and they say, I've never seen anything like her. And ion propulsion at that. They could teach us a thing or two.
Dave, I'm very disappointed you didn't attempt a Scottish accent there.
With their, I'm sorry. You're right. but yeah. Well, anyway. So yes, it was a successful test. They actually had developed two different ion thrusters for this, a cesium engine, but it couldn't be started. There was a electrical short in the system, and so they couldn't actually get it to start. But they did have a mercury ion engine, and that worked. It worked for about 14 minutes. No, I'm sorry. It started about 14 minutes into flight. It operated for 31 minutes. But again, like I said, I was surprised too. 1964, and they were already testing out ion engines. Okay, so all right. Well, I'm not going to spend a lot of time on Apollo 11. I mean, we're July 20th or 21st if you're going to be a Brit about it. But we landed and walked on the moon. Obviously Armstrong and Aldrin. The little interesting story that goes with that, and probably you've heard about it, or maybe you remember it. I do remember it. Luna 15, which was supposed to be a sample return mission, was also launched and was orbiting the moon at the same time as the Apollo 11 mission was going on. It was sort of their last-ditch effort to get samples from the moon before the United States. And so they actually launched this really before it was ready, and it just didn't work. And they did have later sample return missions that did work, but unfortunately, or fortunately, I don't know. This one failed and crashed. And there was some concern that it was going to interfere somehow with the Apollo 11 mission. It never really did. You can see it crashed a pretty good distance, and again, space is a big place. There wasn't really any danger that it was going to smash into Apollo 11 or something, but there was some concern that maybe the Soviet Union was trying to interfere with the mission, all sorts of things. Did not happen. Also July 20th, so only 6 years ago, the Hope orbiter, United Arab Emirates, launched their mission to Mars. Yeah, pretty successful, exciting mission. The first Arab country to launch a mission to another planet, and some beautiful. Well, you see that beautiful picture of Mars on the right there. It returned quite a lot of pictures, data, and very successful mission, and sort of congratulations. But that was 6 years ago. July 22nd, Venera 8 lands on Venus and transmits data. This was there was just a whole string of these Venera missions. They got sort of more and more successful. This one did not have a camera, but it transmitted data back, measurements of the temperature, pressure, light levels at the surface, which was one thing that they were concerned about, because with all the bright clouds on Venus, they really weren't sure how much light was reaching the surface, how much was getting reflected, and how much was reaching the surface. This had light meters on it, and they found the surface was. They usually describe it as being similar to the Earth's surface on a very cloudy day. So plenty of light anyway for them to conduct future missions and be able to, take images of the surface and all without spotlights, things like that. It was only the second robotic space probe to successfully land on the surface of Venus. Also, the other little part of this was, and usually the Soviet Union launched missions in pairs. Now that's how they did things in case one failed. And in this case, they did launch another one with this one, and it did fail. When a mission failed to leave Earth orbit, they renamed it Cosmos to kind of disguise the fact that they failed. So what would have been Venera 9 became Cosmos 482. And this is actually the mission, and we talked about this, I mentioned this in May, that after 53 years, in 2019, on May 10th, it re-entered the Earth's atmosphere. It had been kind of lost, and then it was rediscovered, and then they discovered that it was actually on a trajectory to re-enter the Earth's atmosphere. And I don't know if you remember, I remember following it, because from day to day they were trying to sort of zero in on exactly where it was going, when and where it was going to land on the Earth, and so it did fail to escape the low Earth orbit, but it remained in orbit around the Earth for 53 years before re-entering, and that was supposedly Venera 8's sister ship. Whoops. Chandrayaan 2, it was a lander rover mission. Unfortunately, the rover failed. The Vikram rover crashed when they tried to land it. But Chandrayaan 2 itself was and is a quite successful mission. An amazing picture there of the Apollo 11 landing site, and it again was a quite successful, and the Indian Chandrayaan missions were very successful missions. All right, so.
Sorry, Dave, it's worth pointing out that 5 separate countries have now imaged the Apollo landing sites from Lunar orbit.
Is that right? I guess that's okay.
Yeah. So if you meet anybody who denies the moon landings ever happened, what they don't have is denialism. What they've got is paranoia.
That's right.
So
or somehow we convince all these countries to go along with this gag.
Absolutely. Yeah. They're completely mad as hatters.
So July 23rd, 1972, 54 years ago, the United States launched a satellite which was named the Earth Resources Technology Satellite. This is the very first one of these ERTS missions. Shortly afterwards, and you may recognize this was the first image it sent back, and you may actually, this may look very familiar to you. It was shortly thereafter renamed Landsat 1. So this was the very first of the Landsat satellites. And of course, the Landsat missions changed our view of the Earth. An amazing group of satellites. And this was started in 1972. So we're really talking 54 years ago. The images sent back by Landsat of the Earth's surface at all different wavelengths, and in very high resolution, and showing changes to to everything, to the oceans, to the land, to the surface, to the atmosphere. They've really been a key part, and a very key part of, because they now are, many of these images are 50 years old, a very key part of our understanding of what kind of changes the Earth has undergone in the last 50 years, and how dramatic that's been. Okay, this is. I hope everyone remembers this, or at least the comet. July 23rd, 1995 was Thomas Bopp and Alan Hale independently on the same night spotted comet Hale-Bopp and reported it, and so they shared credit for its discovery. And I still remember, just every night you go out and walk the dog, and there was this comet in the sky, and it just if you knew the night sky, it didn't belong there, and it was beautiful, and it was amazing to just see it just hanging up there. July 23rd, 2020. All right, 6 years ago, Chinese launched their first Mars mission, Tianwen-1. It consisted of an orbiter, a lander, and a rover. Went into orbit in February of 2021. The lander rover portion successfully touched down on Mars and made China the third nation to make a soft landing on Mars. Again, part of a string of successful Chinese missions, sort of one after the other. Most of those, of course, about the Chang'e missions to the moon. They really seem to have avoided a lot of the failures, and possibly a lot of that because the Soviet Union and the United States kind of paved the way and did come across a lot of the problems. But even so, we see what's happening now with commercial attempts to land on the moon, and they're it's hard stuff, and they were able to do this, even a Mars mission, sort of on their first try. Okay, this is very, very interesting, and you may not know about this. July 24th, 1954, moon bounce. So this is the first voice transmission reflected from the moon by the Naval Research Lab at this site in Stump Neck, Maryland. And there's the antenna on the left. The antenna in the center is actually on a ship, which I will get to in a minute. And then on the right there is the original sort of theory about how this worked. James Trexler was the person who came up with the idea that you could use the moon, really technically the moon's ionosphere, and the moon's ionosphere is not anywhere near the Earth's ionosphere as far as its strength, but it still is strong enough to reflect. It's what's called a surface-bounded exosphere. So the ionosphere on the moon goes right to the surface, unlike the Earth, and it is strong enough, even with the tenuous atmosphere, to reflect radio signals. And so they built this. They didn't build it originally for this purpose. They built a 1-acre parabolic antenna, and that's what you're looking at there on the left. And on July 24th, 1954, appropriately enough, James Trexler himself spoke into a microphone at the Stump Neck radio antenna facility in southern Maryland, and his words went to the moon and bounced back to him 2.5 seconds later, and he received the voice transmission. Now, this might seem like a fun thing to do, right? Oh, this is cool. We can bounce off the moon. Okay, well, that was a nice experiment. Let's go on. Turns out, this was actually a really useful thing, and the Navy kept using this. So by January of 1956, the Navy was transmitting teletype signals from Stump Neck and Oahu, Hawaii. And by 1960, the Navy had a communication moon relay system, which began transmitting two-way radio communications. They finally, in '61, sent a message to a ship, the USS Oxford, in the Atlantic Ocean, which is what that antenna in the middle is. That's the antenna on board the ship that was used to send and receive radio signals. And they were, at the same time, they were developing these, what they call signal intelligence, SIGINT, collecting ships. But they were very concerned that the that lower ship-to-shore communications were not really secure with high-frequency radio signals, and they, well, for one thing, they had to count on the ionosphere being. Well, shortwave radio, I mean, you may know this, right? That shortwave radio, you can sometimes receive it all around the Earth. Sometimes you can pick up radio signals from thousands and thousands of miles away if they bounce off the ionosphere. But the ionosphere is very sporadic. In other words, you can't count on it like that. So they decided actually to use the moon, and they were doing this up till past 1964. They were still building these what they called auxiliary general technical research ships. They were called that because they were basically using them as spy ships, but they were disguising them as research vessels, researching all sorts of areas around the Earth that were, on various sides of the Soviet Union for the most part, doing all their quote unquote oceanic research. But they used these SIGINT ships, and they actually used this moon bounce technology for their radio communications on these ships. So, interesting enough, even though this seemed like at the time, I think, oh, wow, can we do this? I don't know, we should try it. Oh, yeah, look at that, it works. It actually became a part of the, the naval communication system. It actually became a vital part of the naval communication system. Now, around 1964, 1965, they finally stopped using our natural satellite and started using, making use of artificial satellites for this exact same thing. But the very first satellite transmissions, I guess you could say, were from the moon. So
that's amazing. I've never heard that before.
I know. I thought this is a really cool thing that I hadn't heard either.
Thanks for that, Dave. That's really interesting.
It's fun. July 25th, 1984, the very first woman to walk in space, Svetlana Savitskaya, who was her second mission, and she walked in space with her crewmate Vladimir Zanipikov. They walked. They were out for 3.5 hours, and so again, the very first woman to walk in space. Also, that was her second flight, and that made her the very first woman to fly into space more than once. So quite a pioneer, and probably a name you may not have heard.
Yeah, no, that is not a name that, sadly, I'm familiar with at all.
No, me neither. Yeah, so it's cool. This is just kind of a funny one. 1609, Thomas Harriot makes the first drawing of the moon seen through a telescope. So I guess on this date, he's credited with appearing on the moon through a telescope, making that drawing you see there. Not much to it.
Let's be honest, he was a crap artist.
All right. But let's see you become the first person to draw a picture of the moon seen through a telescope, huh?
Yeah, all right.
No, I guess, I don't know. We may need to count on, I don't know, Roger and Michael maybe can tell us where on the moon that is. I assume it's well, I can't, what, I'm not even sure, I guess, where that is in the sky. Obviously, sort of a crescent moon, a funny looking crescent moon, but whatever. And he did see, managed to see some features. I can imagine the telescopes at the time were,
no, exactly,
pretty rudimentary. So this is anyway. It's quite a first step towards everything we know now.
By the way, Fred says Pacificon a few years ago, ham shortwave convention. I remember some presenter talked about doing moon bounce. So it's
okay.
It's still around. Yeah.
Cool. Yeah. Just a really interesting. And Stump Neck, Maryland. I'm not terribly far from where I live, so I should. It is now called. It has a new name now. They renamed it Naval Surface Warfare, something or other. But so I don't know if I could actually go visit it. Something that says the name Warfare in the name is maybe not open to the public. I don't know.
No.
All right. Really quick. July 30th, 1971. Apollo 15. First lunar rover. Kind of neat. I still pretty iconic images and videos of those lunar rovers bouncing around on the moon. Mariner 6 flies by Mars on July 31st. We mentioned this when we were talking about Viking.
Yeah.
The information that they got from Mariner 6 and 7 were very very important to their early planning for Viking. When they got the better and more complete pictures from Mariner 9, it helped. But again, and actually these were the ones that they kind of fooled them, because they basically, a lot of where they flew by, and it was just a flyby, so it was just a sort of a strip of 26 pictures, I think, that they took, that Mariner 6 took, and then Mariner 7 took a similar amount. Happened to show like just a lot of cratered areas and stuff, and it didn't show the best of Mars. It showed a very lunar-like landscape, so it was a little bit misleading for a while before they got Mariner 9 got there. And that's what I got. Oh, next week, so covering August 2nd through the 8th, I've got As Seen on TV, Not So Baby Steps, a satellite gets a sub-satellite, Mars Mixed Messages, Curiouser and Curiouser, and Sampling the Sun. I realize I read these and I feel like I'm giving you Jeopardy categories or something.
Yeah, well, I thought it was the Daily Telegraph cryptic crossword, to be honest. But,
oh yeah, that would work too. Yeah.
Yeah. Okay. Thank you so much, Dave. Really.
Before we move on, Andy, can I just we were talking about the ion engines there in 1964 when they were first sort of being developed.
Yeah.
And I know I've mentioned this before, but on the Dawn mission, which visited Vesta and
I remember.
Ceres, that had ion engines, and although the acceleration rate was absolutely phenomenal, the G forces would wreck you. It went from 0 to 60 in 4 days. That's how fast it was. But actually achieved, and it became the fastest man-made object in space by achieving, when it got ramped up, it actually traveled at 25,700 miles per hour, which is 11.5 kilometers per second.
Wow.
Which was 2.7 times for velocity of the previous record, which was also held by an ion engine. And the ion engine actually achieved 5.9 years of ion runtime by September the 7th, 2018. This amount of runtime equates to 54% of Dawn's time in outer space. So these engines, although they're not the fastest things to get you going, they really do ramp up, and they really do thing. Of course, the speed record now is held by a man-made object, is Parker Solar Probe, but that's through gravitational assists and that. So I just thought I'd throw that in there.
No, they're incredibly efficient. I mean, you just have to be patient, right? But they effectively they make use of every atom of fuel.
As long as you're not in a rush. That's
right.
Okay, so this is going to be interesting. I've got a question for Dave. What is this?
Is that a moon tree? It looks like a moon tree.
It's a moon tree grown from the seeds that flew on Artemis 2. It was officially unveiled in New York last week.
All right.
This was grown from a seed that flew to the moon with Artemis 2. Dave, as you may know, is the expert on the original moon trees that flew with Apollo. And if you want to know more about that, see our video about it, where Dave talks about it. So that's that. Okay, another thing, just interestingly, just give me 1 second to put this up on the screen. A pub called the Space Invader has unveiled a Jodrell Bank mural. in support of Jodrell Bank. That's somewhere near Jodrell Bank, I think. So well done, Space Invader.
You must pay a visit.
Yeah,
That's excellent. That's
so
excellent.
there's that. Also, just before we move on, you may remember, I think back in October, that astronomers announced that they discovered that Betelgeuse has a companion, that in fact it's a binary system. They weren't really able to get an image of it, but the European Southern Observatory has used the VLT to come up with this image of the companion of Betelgeuse, which is shown in the crosshairs there. And Betelgeuse is in the center, but it's been masked out. And there very clearly you can see Betelgeuse companion star for the first time. So this is all fantastic news.
Yeah.
And we don't know how much that was involved in the great dimming of Betelgeuse in 2019, which you may remember, we've talked about it. But the fact that we've now got a direct image of Betelgeuse companion star, which is obviously quite a bit smaller than Betelgeuse, we'll have to wait and see what we can find out about it. So there's that. And
I hope they don't find a third one, because that'll be Betelgeuse, 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 and we know what happens then.
Very true. So before we go any further, a word from our sponsor. This video is sponsored by Picastro. It's like Instagram for space nerds. And as usual, thanks to Tom for sponsoring Space Oddities.
Oh, this is interesting. Sorry, can I just interrupt, Andy? I'm just putting this up from Derek.
Yeah. We are Mintry Granging Runcorn, really?
Okay.
That's really good news. And we'll just get rid of this, and we will carry on. For some reason, I can't get this off the screen. Let's see what I can do about this. Oh, that's very interesting. There's only one way to do this.
As we get
it. Oh, not that.
We didn't do any.
Okay. So yeah.
Moon tree.
That's the moon tree. So fantastic news. So I can't get rid of that either. Give me 1 second. Something's playing up here, but I shall fix it. Right, sorry about that. We had a slight technical hitch there. Seem to have lost Dave though. Well, never mind. Okay, we're going to move on now, and we are going to go over now to Roger. So, Roger, what have we got in the night sky gallery?
Okay, let me go and get it up for you. Right. So here we go. Okay.
I'm getting the blame for all that.
Right, okay, here we go for the end of July and the start of August. Ooh.
Dun, 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 dun.
Okay, so it's the 28th of July to the 3rd of August. Okay, here we go. So, where are we? We're just about to come into the full moon through the hours of tonight. It's going to be called a buck moon, as it likes to be called in America. Obviously, because of the rapid growth of the male deer in the midsummer, so it's getting ready for mating and all that sort of malarkey. So there we go. So there may be an opportunity. It's looking quite clear out over this way anyway. So we'll see how it goes. So while we are looking up at the night sky, we can clearly see the summer triangle pretty much overhead. And as we can see also, we've got the square of Pegasus and Andromeda coming up quite nicely to view that lovely big galaxy. But we are now, before midnight, getting Saturn to come up into view now. So Saturn will become quite a nice object through the hours of the morning and through the night. It will get to about 40 plus degrees above the horizon, so it's a good opportunity to get some observations of the ring planet. And obviously with the 9 degrees of ring tilt, we shall start to get lovely views of those rings again, as we will always do. Obviously just before sunset, we do have Mercury very close to the sun now, so that will not really count as an observable object. And obviously Venus is now getting to a similar altitude when the sun is getting down low, so there isn't much of an opportunity, but there is an opportunity still to see Venus before sunset. That's provided you've got a low enough westerly horizon. But as you can see here from the hours, well, this is early morning, we do have Saturn quite nicely, and we've also got Mars at a good height as well through Gemini. And then we've obviously getting Jupiter coming up, having passed through the other side to become a morning object. So interesting to get some opportunities there if you haven't seen them for a little while. Okay, so obviously we need to look very carefully, as I said earlier, to have a look at these after sunset for Venus. And well, it says here it reaches 30 degrees above the horizon before dawn, but it will get up to 40 plus degrees later on as the days and weeks and months go on. So becoming quite a good target to achieve to see. And then we've also got Mars. Unfortunately, due to its distance away from us, Mars is quite a small object in respect to seeing what the disk of Jupiter and Saturn are, but it is a nice object to be able to spot when you can get to see it. We do have some meteor showers. We've got the southern delta Aquariids, which peak over the next few days. So it will be a bit of a challenge, unfortunately, with the full moon and waning gibbous moon through this week. So it does become a bit of a challenge, but obviously as it sets into the early hours of the morning, there might still be an opportunity to catch some of those at an opportunity. And we've also got the Alpha Capricornids as well, which is not too bad, but obviously we're having a bit of a challenge there with the moon glow as well. So it's obviously going to be a bit of a challenge anyway. So this is how the sun was looking today. We're getting quite a few sunspots spread over both the eastern and western limbs. No major prominences available, but there's an interesting coronal hole down towards the southern parts of the sun. So whether that will give us any problems with that being down so low is another matter. So here we go for this week's gallery, and obviously it's been hung over from last week, so we do have quite a few images to have a look through. So here we go. And we do have some wonderful pictures, as we always do. So first one, as we usually get from Michael, our weekly subscription of the images which have been mentioned with the active region numbers, and this was taken on the 23rd of July. And as you can see, we've got some very nice large sunspots there, and obviously these have now pretty much moved all the way around to the edge. Obviously 4492 is right on the edge now, as we are aware. That's well done. And then we've got Jerry DeLay with the Dumbbell Nebula with his Ritchie-Chrétien 6-inch telescope. And here we go.
Oh, that's lovely.
Oh, nice.
That's
amazing structure.
Well done, Jerry. Another winner. Wow.
Beautifully processed. Well done.
Yep.
And here we got one from Daz, C20, which has nearly 2 hours with a C-Star S30.
Oh, nice.
Very nice.
Wow.
C20.
That's lovely, Daz.
Well done.
Yeah,
Oh,
it took
yeah.
a bit of pulling out, but it's very faint. But it took that's why it's 2 hours. But it took a bit of pulling out. But there it is. It's want to get some more time on it though.
You're going to do a Tom, or are you going to spend about 50 hours on it?
Hey, I'm going to do 50 days.
Yeah.
And not to leave his C-Star S50 out, he's done the M13 with 47 minutes on this one.
Oh,
wow.
Yeah, that's brilliant.
And also with the Galaxy up above it.
Oh, yeah.
Oh, yeah. Yep. Oh, nice.
Well done, Zaz. Right, okay. And then we've got one here from Craig. On a Saturday morning at the Football College Observatory, there's a solar viewing through their main telescope. Through the main telescope, sunspots are visible, and there is a secondary telescope which he thought had a HA filter, which allows the prominences to be seen. So he attempted to take some pictures with his cell phone, but only the solar prominences had any mediocre success. So this was on the July the 25th, and this is what he managed to get. And we can start to see some of the prominences up on the, well, right at the top, and then at about a 2 o'clock position.
Yeah.
Really nice.
Yeah, so and I think there's some hints of sunspots there as well, just about.
Beautiful image.
Well done.
Yeah.
It's a very, very tricky if you're if you haven't got a proper phone holder against the eyepiece, but well done for getting that.
Indeed.
Here's a few from me. This was the moon on the 20th, which was during the evening, so you got a bit of the blue sky here. That was
Nice.
a little while ago, right? And then I've managed to do a little Milky Way stack.
Oh.
And,
Lovely.
And that's what we got from there. I did do it through the whole of the night, but some of them were a little bit obscure with some of the clouds. But these few that I did stack together did turn out to be quite reasonable. And then I've got yesterday the sun with the calcium and some hydrogen alpha.
Very good.
So it just gives you an idea of some of the activities going across there. And I got the hydrogen alpha with the active prominences that were available to see yesterday down on the bottom there.
Nice.
Yes.
Lovely.
Okay, and another picture of the moon, which I also took last night. Managed to sort of get the colour up to get some of the mineralisation of the surfaces there. So it was just coming up to just 2 days ago. So last night it was too cloudy. So this night might be an opportunity to just try and get a full moon shot. Okay, so that's what we have for that on the What's in the Night Sky in the gallery.
Okay, thank you very
Good
much.
one. Yeah,
Fantastic.
nice.
Okay, well, there were some lovely solar images now, and Daz is going to now give us an update on exactly what's been going on with our local star.
Good job I didn't drop off, wasn't it?
Yeah, absolutely. Wouldn't be the first time,
No.
Drop off me perch. Right, this is just going to be a quick update. We haven't had one for a while, so I thought I'll just bring this up. So let me just share this.
Right.
Right. Okay, then. So we know that this that for people who are new here, the solar sunspot cycle is an average of 11 years. And the reason it's an average is that it can be as short as 9 years and as long as 14 years. And it's just basically a cycle that the sun goes through, as we say, every 11 years, because that's the average. As you can see here, you can see this is the plot for cycle 25, which is what we're in at the moment. We're definitely on the way down now, although I have seen some people say that we're still coming off the peak, which I suppose we are in a way, but we are definitely on the downside of it now. Now, don't be disappointed. That doesn't mean we aren't going to get any action. In fact, we can get some of the most violent action, if we want to call it violent, most energetic eruptions from the sun on the downward slope. So don't be surprised. In fact, we had an aurora as far down as the Norfolk coast last week. Sometime I'll be able to show you not pictures of the aurora, but when it actually happened. As you can see, it peaked on August 2024, and at the peak was 216 sunspots on the sun's face. And at the moment, well, this is a little bit old. We are now at 94.4. You get 0.4 sunspots, I don't know, but that's where we're running at the moment. And of course, at the bottom here, you can see from 1750 all the way up to 2030, all the cycles that have happened in the past. And as you can see, they do vary. This isn't going to be an exceptionally high sunspot count, so like in 1950s, or you can see where they actually sit. So yeah, we're sort of like coming on. We're on the downward slope, but we will get there eventually. Now, this is just basically the last. Well, it's not actually the last 30 days because I did this the other day. It's actually a list of the sunspots, and including the radio flux. As you can see, it says sunspot number. That is the numbers of the sunspots on the sun's face on the days. You can see I did this on the 24th. And what I've done is I've actually boxed when in the last 30 days we've actually had some action on the sun, which has actually affected us on Earth. Not massively, but this was the last one that happened last week, and we got some auroras from it. So that's where we stood there. Now, if you can remember, this is Bartel's music. This record goes all the way back to the 1930s, I think it is. And you can look at this. The reason they call it Bartel's music is it looks like a music score.
It does.
Yep, absolutely.
Yeah. So basically, this is 2024. This is January to July. So this is what we've had just this year. As you can see, in January we had quite a big events happening here, which lasted for a week, a few days. And what it is, when you see the black spots, these are actually solar storms. They're actually KP indexes that happened on that day. So, and this is where we actually got actual events happening on Earth, even if it was just high altitude auroras or auroras down to the southern latitudes. So we are getting events that are happening. They're still happening here. They're far and few between. But and it was this. If you can see my cursor, it was this event here that gave us the aurora the other day. In fact, it was actually on the 24th. These are, if I remember, 3 hour, because it's a KP. Each of these lines is 3 hours apart. So that's what we're looking at. So that's what the Bartel music. So as I said, we are getting events that can cause aurora as of now. This is a bit blown up. This is March to July, so this is a little bit thing. And again, you can see this was the event here that actually gave us some auroras. Now, as you can see, this at the top here, you can see it's marked from 1 to 27. That's the days of the solar rotation. It takes about 7 days to rotate. So of course we get virtually 13 to 14 days of events, actually any sunspots or anything like that on the sun's face when it's actually looking at us. So let me move on. I'm going to do this quickly. Again, here's the event that was I was the 23rd of July here, and the KP index actually rose to 6.333. So all recurring, I should think. And again, this is the HP 30 index, which I prefer to be watching at. If I know there's events coming, I'll look at this, because each of these columns is only 30 minutes long. So if you've got an event and you think it's coming towards you, you can watch for any sort of like reaction. The scale's exactly the same as the KP, so that 6 is usually a storm force, which will give us aurora. But these are 30, so you can actually possibly get a chance of seeing it start to build up. You can then rush out, get your equipment out, and take photographs of any auroras that do appear. So I do like this, but this one hasn't got an alert on it, so that when it starts to pick up. But yeah, as I said, this is only 30 minutes, I think. Now, we were talking about, this is last week, we were talking about, this is one of the signs. This is a coronal hole. Now, forgive me now if I keep calling it a black hole. For some unknown reason, I get in my head, I'm just nuts. So this is a coronal hole. Now, when we come to the downward slope, or the receding sunspot part of the cycle, we will see these coronal holes become very elongated across this, and they will stretch from south latitudes to north latitudes, crossing the equator. And when we see this start to happen, then we know that we're on, the receding side. This just helps. Now, this is the active region that gave us all the action last week. Is it 4963? I may get that number wrong, but it's AR. It's the active region. Now, this one gave us a few flares last week, but it also did something else to this coronal hole here. Usually, we'll add to this. When you see coronal holes in the peak, we will see the coronal holes up here. They can be very, very large, but they'll either be in the north or the south, usually. So that's it. Now, this is the sunspot. Oh no, so it's 4493. Mostly the right numbers, but in the wrong order. So it's 4493. So this is what it looked like. This was hasn't got a date on there, but it was designated. It first appeared and given its a number on the 7th, the 20th of the 7th, 2026. This is sort of like just an image that you can see, a white light image. Now this is using you're looking at the magnetism within this these two sunspots, because they are connected, and you can see you've got the red and you've got the blue, so you've got positive and negative. And what you're looking for is round here is when they start to sort of like mix together and start touching it. They don't want to be together. And this is when you can get action occurring, because you'll get flares going off and things like that. There is actually a scale to that, but it's something that I've spoken about in the past. So here is a synoptic map. Now these are drawn every day. And again, we've got the long coronal hole. This is the coronal hole. You've always got an outline, and then you've got these little spikes poking in, so you know that's a coronal hole. And it's 79. It's been numbered 79. Here's the 4493 active region, and as you can see, it actually sits in this little cavity. And again, you can see other active regions on here. These little worm-like things, these are actually filaments they're prominences, but they're on the sun's face, and this is how they appear to us. And you've got your positive and negative regions all around. So I think I've got did I put it on here? There was a solar flare from 4493. As you can see, it's actually changed here. It actually looks different. And it gave us a solar flare of M2.5 on the 20th of the 7th. and it was sort of like in the afternoon. But now, if I've got it right, now watch this. Here's the coronal hole. You can see it there. You will see all of a sudden this all light up, and it will push into the coronal hole.
Oh, wow.
There. So
Look
that
at
one
that.
actually pushed into the coronal hole, and the effect of that, because it kept on flaring, it didn't just do one flare; it did several flares. Here it goes again. You can. I'll just let you watch it again. You'll see it. I'll push into this coronal hole. You can see it's already pushing in, and it all lights up, and it pushes, but it's restricted by the actual edges of the hole.
Wow.
Now, the effect that this had, that's another image.
Wow.
This was another one from the same region, but this was on the 22nd. So this was firing, giving us some action all the time. So let me just pass on. Now, this is the synoptic map drawn on the 24th. So we're 2 days after that happened. And look what's happened. The coronal hole is now split into two.
Huh.
And so they've had to renumber. That was 79, remember, and now this is now 81. So that is it, and you can see 4493 is now actually sitting between them. So, but all that flaring and all that action and all that actually helped to split this up into smaller regions. And we have had smaller coronal holes in the north and the south, but they've faded away. So I think that's it for now. So that's it. So we have got some action going on. Hope you enjoyed that.
Thank you, Daz. Thank you very much indeed. Again, I can't seem to get rid of this off the screen.
I'll do it. Don't worry.
Yeah, if you could. There we are. Thank you. Excellent. So thank you, Daz, for that update. As always, the sun remains active. Certainly for the moment. So we might see some more aurora, we might not. Who knows? It's in the lap of the gods. Anyway, just a couple of housekeeping things before we go to our final presentation for this evening, which is predictably Michael's constellation of the week. So, and
that won't take long.
No, no, absolutely. And don't forget, if you would like to support Space Oddities, you can keep our caffeine levels maintained by buying us a coffee. You can click the link in the chat, or you can scan the QR code here. And any contributions towards our caffeine would be greatly appreciated. And you are directly helping us keep Space Oddities going. And if you would like to see us continue bringing you the science that we enjoy doing on Space Oddities, and obviously we hope you enjoy it too, then you can buy us a coffee. You can also, of course, buy your Space Oddities t-shirts. As always, still obviously t-shirt weather. And I've been looking at the long-range weather forecast for Europe, and it looks like certainly France and Spain and possibly the UK are going to experience drought conditions until at least the middle of September. So you'll need a t-shirt, and what better t-shirt to buy than a Space Oddities t-shirt? You can scan the code here, and you can also hopefully click the link, which has not appeared in the chat, I just noticed. Anyway, scan the QR code, and you can also get your hoodies there at the same place. The t-shirts are £20, including UK postage and packing. So there we are. So we're going to move on now to our last thing for this evening before we leave you. And we're going to go over to Michael for Constellation of the Week.
Okay.
Corvus.
Corvus, it is. This is Corvus. The Raven is in the southern sky. One of the sky's oldest constellations, steeped in myth, mystery, and modern discovery. How about that? Another small constellation.
Really, Michael? I would never have predicted that.
Just 5 or maybe 6 stars linked in this constellation to make up the pattern. But as you can see, it's very low, very close to the crater, which I talked about a couple of weeks ago. And they are all part of the Hydra constellation. Well, not part of it, they're all next to the Hydra constellation. And I'll come onto that in a little bit. An ancient omen, the Babylonian raven, known as the raven since 1100 before Common Era, BCE. In ancient Babylonian astronomy, the constellation Corvus represented a raven that was sacred to Adad, the Mesopotamian god of rain, thunder, and storms. Corvus this is Corvus as depicted on the Manuchi globe. Probably said that right. Made in Mashhad, 1632 to 1633 AD, and is part of the Adil Noor collection in Sweden. And this is another depiction. And again, because it's close to crater, the myth of Apollo and the raven is the same as that of the crater of the cup. Apollo sends Corvus to the raven to fetch a water in a cup. The crow lingers to eat figs, then blames the water snake Hydra for the delay. Apollo casts the crow at the cup, and the snake eternally into the sky, and that's why it's depicted there. Okay, mapping the raven. It's 17th in size, and one of the 88 constellations. It's the sail, call it a sail, that distinctive quadrilateral asterism, also called Spiker's spanker.
Oh, matron.
Take them away.
Location south of the Virgo, near the bright star Spiker. Okay, the brightest beacons. These are the stars in Corvus. First one, the brightest star is Gienah, I think.
Oh, Gienah.
Yeah. or Gamma Corvi, the brightest star, an aging blue giant 153 light years away. And again, another constellation where Alpha is not the brightest star. I didn't know there were so many. So the next one is Kraz, or Beta Corvi, a massive yellow giant. And then we've got Algorab and Vinkar, key stars defining the crow's distinct shape. Okay, what about celestial treasures? This is the antennae galaxies, NGC 4038 and 4039, a colliding pair of galaxies 45 million light years away. Very nice one, very nice as well.
Lovely. And
this one is NGC 4027, a barred spiral with an asymmetric arm from an ancient collision. Another nice galaxy there. This is NGC 4361, a striking four-lobed planetary nebula. Okay, Corvus is also home to a dwarf nova TV Corvi, a white dwarf and brown dwarf in a tight, intense orbit. So, exoplanets, 3 confirmed exoplanetary systems within Corvus. Eta Corvi, young star with 2 complex debris disks, possibly planet forming. A little bit of trivia now. In 2012, DC Comics reached out to astrophysicist Neil deGrasse Tyson to help their character Superman, the Man of Steel, locate his lost home world for a special storyline in Action Comics number 14. Tyson gave Superman's home planet Krypton a real-world address. It orbits the red dwarf star LHS 2520. There you go.
Oh, wow. There you are.
So if you ever want to go and visit, yes.
Yeah.
And just final slide, to find Corvus, look west of Spiker to find the Raven. It will be visible in UK skies a bit later on. You just need to look towards the south. It'll be very low on the horizon. And that is it.
Thank you very much, Michael. Thank you very much indeed.
Yeah.
Yes, another winner. Okay. So we are going to draw things to a close for this evening. We would like to thank you all for being here, as always. Thank you so much, guys. And we will be back next week. Now, by unpopular demand next week, it's back. Next week is quiz night. Yes, we're going to do your quiz. Your host for next week's quiz will be Lou. He will be posing the questions. Bring your paper and pen at the ready, because we will have a fun quiz next week. If you haven't attended one of our quizzes, well done. And it will be on astronomy and space and all that stuff. So next Tuesday on Space Oddities is quiz night. We normally have a lot of fun with the quizzes, although absolutely nobody on YouTube watches them. We get views that are barely in double figures sometimes, but we do enjoy bringing them to you, and we know that you enjoy them as well. So
well, I'll tell you what we'll do is, just to whet their appetites, I'll donate a prize. I will donate a very, very rare Space Oddities mug.
There you are. Thank you very much, Daz. I didn't even know there was such a thing as a Space Oddities mug. Have you actually made it yet?
I got one here. I had one made for myself. So there'll only be two in existence.
There's dedication. So thank you. Daz is donating a Space Oddities mug for the winner of next week's quiz. So make sure you attend and win yourself a Space Oddities mug.
Well done, Daz.
Great. All right, then. Have a fantastic week, everybody. We do enjoy your company so much on Tuesdays. Thank you for all of your contributions this evening. Take care of each other. Be good. And if you can't be good, be average. And we will see you same time, 8 p.m. UK.
Sign the petition. Sign the petition.
And sign the Jodrell Bank petition. That's very important. We'll keep you posted on what happens with Jodrell Bank, obviously. Take care, everybody.